Okay. Okay. For this problem, right? This is just only the brief answer. Okay, brief answer. The example of the brief answer for bracketing method and opening method. Which one is the bracketing method? Which one? Which one? Bracketing method. Bracketing method is correct. For bracketing method, it is the technique that requires to introduce with bracket the root. Consequently, they always convert because they move close to the root as the computational progress. Okay, so the keyword for bracketing method is request to introduce that bracket root, and it's always convert. It's always converse. You alright? But for open method is requires one or two integer that not necessary to bracket the root. One or two integer that not necessary to bracket the root. Okay. Then sometimes divert because you try you have calculate one integer. So then it's maybe divert. But if it's convert very fast. All right, this is just the example of the definition. For next, we would like to determine the straight invariance. Straight invariance means that this value I1, I2, and I3. Okay, straight invariance is I1, I2, and I3. According to the straight tensor here, okay, according to the straight tensor here. So then, according to this value, you know that my x is 20, right? Sigma y is minus 50, right? Okay. Sigma zz is 65. Sigma xy is 10. Sigma xz is minus 6 according to the straight tensor, right? Sigma yz is equal to 31. Based on this formula, you can mean straight invariant I1, I2, I3, right? Are you okay? Are you okay? Can you do it? Okay, you can use Excel or something. Okay, are you ready? Okay, so then after we have straight invariant, we can form the equation to determine the principal straight by this. Okay, just only substitute I1, I2, and I3 in the equation. And we will find out this is the nonlinear equation that we would like to determine, right? You okay for that? Okay, you alright? Understood? Yeah. Okay, we may start. You may try using your computer, or you may use your tablet. That you may use number. That's up to you. Okay, or you may use Excel. That's up to you. Okay. We have this equation. Are you okay? We have this equation, right? Then it should be x, and it's fx, right? Okay. So because we don't know what happened for sigma, right? We may start is maybe 0 or something that is up to us. Okay. And actually it should be sigma, right? Okay. And it is the function of sigma, right? It is over here. Okay. That is equal to what? Is equal to this value, right? Okay. Power 3, right? Okay. And minus, because we already complete to determine the equation already. Okay, that you may solve it by hand, or you may use Excel to determine this value or something. It's up to you. Right. It's around minus 35, right? Sigma, right? Where, right? And minus, okay, plus, are you okay for that? And how about if it's maybe 1 something? You may about this. That is just copy the stress on this. Okay. That is, you will see that it's not very close to 0, right? Okay, so then it's maybe consider the principal stress to guide us. It's come from 20 because the principal stress is what? Principal stress is the normal stress on the plane that has no shear. Okay, so then we have the principal, we have the normal stress here that is around minus 50 to 65. Okay, so then we may starting with around minus 60, I think. Okay, and it's maybe minus 50 or something. Okay, and then you see. Okay, and after that, we may try to plot it. Okay, are you ready? Can you find how many root? How many root? We can mean for 3 root right now, but the first root is maybe not clear. It's maybe not clear. We may change a little bit. Okay, now it's maybe better, right? Okay, can you see this graph? Okay, from the graph, you may plot it by yourself. Okay, you may use your computer. Who has the computer? You have tablet, right? You can use number to plot the graph. It's up to you. Okay, you can try it by yourself. Okay, after this, we can plot a graph like this. Okay, and then back to our slide. According to this equation, we can plot the graph like this, right? It's the same. And from the graph, how many roots that we can find? How many roots? It has 3 roots. Okay, that's match to 3 principal stress. Okay, normally we define the maximum value as sigma 1. Okay, and the minimum value as sigma 3. Okay, so for in this case, the maximum value it should be here. Okay, it should be here. So we moving next, we plot the graph and we found that it should have 3 values, 3 roots. This is the first one, this is the second one, and this is the third one. Okay, the first one is between what? Is between, is around from the graph. From the graph, is being very close to 70 and 80. Okay, it's maybe 20 something, right? Okay, and for the second one, it's between 20 and 30. So then it's maybe around 20 something. Okay, and the last one is maybe minus 50 to minus 50. So then it's maybe around something, some value of that. It's maybe around minus 50 something. Are you alright? Do you understand? Okay. So we have 3 principal stress. Okay. And the problem would like you to determine. Use apply 3 methods that we studied. First one, bracketing method. Second one, Newton. And the third one, second method. To determine 3 values of principal stresses. Okay, each method for 1 value. Okay, do not determine the same. Okay, do not determine the same. In the paper exam also, but you have to know that in the paper exam you have no 2, right? You have no computer. Okay, you have just only the calculator. Okay, that you may have to predict by yourself what for the value for the initial gauge should be 1. Okay, so practice is more. Okay, in order to find the value. Actually, you can use the calculator to guide you for something because your calculator can solve the nonlinear equation, right? This is just a recommendation because in the paper exam, you have nothing, you have no 2 for the graph. Okay, but you have give you the idea. Give me the idea. Why you use that initial value? Okay, I'm not guideline what is the initial value, right? Okay, you have to explain by yourself. But you have to determine all value of income rate. Are you okay? So let's start for the first method. For the first method, we use bisection rate. We move to next. We will use bisection method, right? Okay, because the first one you already know how to answer. Okay, The second one, we already derived the equation. Okay, we already determined the stress invariance and derive the equation in the second one. The third one is to for the graph. We already done. Okay. For class activity, you have to submit the same as this line by yourself. Okay. Practice by yourself. How to do the step by step like this. Okay. I will not give you this line because I would like you to do it by yourself. Okay. It should be better than this. Do the report that makes you understand better. Okay. And submit me the report next week, Thursday, before midnight. Okay, because the class is Friday, right? You set up the class Friday, so then you should submit me Thursday before midnight. Are you okay for that? But actually, if you have computer, you can finish it in class because we will try to finish it in class. Okay? So we're starting with the bracketing method. We're starting with the first value of the principal stress. Okay, back to the graph. If we would like to predict, the first principal stress, that is the maximum value, the maximum value. And we will use bracketing method. We will use bracketing method. We will use bisection method. How about bisection method? How many interfaces that we require to interface? That has to bracket the root, right? Okay? This has to bracket the root. So that, and we would like to gauge the maximum value, the sigma 1. So, what our interface should be? From the graph. What our interface should be for bisection? Where it should be. But for the paper exam, it's up to you. It's not necessary to select the maximum, but just 3 values should be different. Are you ready? Okay, because in the paper exam, you cannot run in the graph. So for bisection, it's up to you. What value will you select to be the initial case? Which one? We require 2 values. It's up to you. I will not guide you. Which one? Which one? Which value? We have a limit of time. If you still quiet, so then we cannot move it to next. And if it has the limit of time, so then we should end. Which one? Okay, we have just only 20 minutes. You select minus 60 and minus 55. You select that. Okay, that's all right. Your friend select that for the first value of principal stress. We will do that. Okay. This is table. It's not necessarily the same. Okay. But in my opinion, this header of the table is very easy to remember. Okay. these two column is just the optional, okay. You may use X instead of sigma actually. If you understand, it's okay. Okay. This is for first iteration, right? Okay, this is for first iteration. And you try what? The first one? Minus 60, right? And minus 55. Are you all right? Okay, is it okay? And then this value should be what? Should be this value plus this one. Okay, divided by 2. Am I correct? Okay. Okay, for individual assessment, you can use Excel. But for paper exam, you have to do it by hand. Okay, but I will set up the limit of step for calculation just only 4. Okay, F sigma is what? Is equal to what? Is equal to this XR, right? Is this value power 3. Am I correct? And minus 35 times this value power 2. Okay, minus, okay, 4047 times this value, right? Okay, and then plus, okay, 92640, right? Okay, you can use calculator to check my calculator, my calculation. And then for the second one, it just should be here. Okay, it is the same, right? Okay, and then is what you check. Okay, and this is just optional. What a percent error we will leave it for the first. Actually, we can leave it for the first because we will compare sigma m, okay, xm and xm for each step. Okay, we will leave it for first. And for the second one, fxl, it should be the same of this value. But we have to change to be here. Why we do this? Because we have to check the fxm if fxl and fxr is bracket the root or not. Okay. So then the condition that is okay. Now it's okay, right? Okay. Now it's okay, right? If we try, I'm sorry, it should be like this. I'm sorry. It should be fxl multiplied with fxr, right? Okay. Okay. All right. This for checking the condition, right? For checking the condition that you may set out the column. Okay. So that is the optional, right? Okay. This is just the optional. This two column is not necessary actually. Okay. Now we move to step 2, right? We'll move to step 2. I change it back to showcase that reflect first. So minus 55. Okay. Then confirm that fxl multiplied with fxr is less than 0. Okay. Okay. We check this. That's really done. Okay. So now the condition that we have to check next for next is what? We will check this condition, right? Okay. If it's positive, what does it mean? If it's positive, what does it mean? If it's positive, it means that x, r, and xm are in the same side. How can we process next? We change what? We change xl or xr. Try to think about the picture. If xr is in the same size of xm. Okay? You found out? This is xm, right? Xm. And this is xm. So then, if xm, fxm multiplied with fxr is positive, it means that xm and xr are in the same side. So then, how can we do? We change what? We change xr to be xl. So then, xl should be kept, right? So if we do something like this, so the Excel will not help us, right? So then we may set up for the condition to this cell. This may be something like this. Okay, if this is greater than 0, right? Okay, if this is greater than 0, so then this cell should be this. Okay, and if it's not, it should be this value, right? Okay, and for this, it should be, if this condition is greater than 0, so then it should be changed to be xm, right? And if it's not, it should be the same. Are you all right? Okay? Are you all right? And then, how about this? It should be the same, right? Okay? And next, we will determine the percent error for each iteration. It is equal to what? It is equal to absolute value of this one minus this one and divided to the new update, the new value, right? Okay, and we would like to determine it to be percent. Are you all right? It's become 2%. So then it's not falling down the percent error that we would like to complete. So then we will proceed for another iteration that is maybe something like this. Okay. Okay, so back to here. Can we finish? The percent error is around 0.002. But our problem request for what? Percent error should be falling below 0.01%. Okay, so according to this, back to our sheet. What is falling below? It should be here. That we can stop, right? Okay, we can stop here. And do not answer me just only this. Okay, we can stop here and the error is falling down below 0.01%. We can stop. And what is the solution? The solution is what? It's very important. What is the solution? Not the table. Table is not the solution. What is the solution? Solution is what? Why not? It's not equal to 0. So according to this condition, you see that if we use the condition for bisection, if we use this condition to compare xm, that is close and is fall below the below that, you will see f(x) is not close to 0. You see, f(x) is not close to 0, right? Actually, it's not a good value, right? Because f(x) should be 0. Okay? But you see, f(x) for both is not 0, right? So then actually we should do more. Okay, we should do more. Okay, so that we can process it until f(x) is become close to 0. And you see that the value of sigma it should be around here. That is maybe give us the very precise value. Okay, because the function that we have is maybe half the bigger number. So then the value for bisection that give us for f(x) is maybe not good enough if we use the stopping criteria like that. Okay, so for these cases, the stopping criteria if it is that like that, that's only 10. Just only 10 iteration is maybe reach the percent error that we set up the criteria. But the value for the number of x is maybe not give us the good value of the solution, right? Okay. So if we would like to have the great value, we may set up is maybe minus 59. What's happened? Oh. And this should be okay. Let's maybe better for that. If we do something that for set up the criteria, but actually it's okay for the first one, set up like this. Okay, this should be all right, but I would like to let you know that actually for something criteria that we set, it's really not good enough because you see fs is not zero, right? It's not zero. So then we should do further to meet the criteria, or we may change the criteria that fx should be fall below. Okay, are you alright for bisection method? Are you okay for that? Are you okay for that? So we move to next. That is maybe the Newton-Raphson. Okay. So for Newton-Raphson method, we have to take the first derivative of the function, right? We take the first derivative of function. So for this function, we take the first derivative to be here. Okay. Okay. And we can determine the new one by this value, right? By this formula. Okay. So then we may set up the table. Okay. Here's the first. Okay. We do the same, right? We do the same. And back to the first sheet. We already done. What value that we get? What value that we get? Get 59 and maybe around here. We already select this for the bisection. So we have this solution already, right? So then for the reduction, what initial case that should be? What should be? If you select the value around here, so you may get the same root, right? Okay. So we should select another, right? What value that you would like to select? Which one? Which value? For introduction, you how many value? How many case that we require? Just we want. So then it's very easy, right? So which one will you prefer for this case? Minus 60? If you select minus 60, that's all right. Okay, you select minus 60, right? Okay, but you may not have the answer that we would like to have. Okay, I will select as your friend recommend. But if it's not have a solution that we would like to require, so then you select by yourself. You do it by yourself, right? Okay, because we have the limit of time. So then I would like you to help me to focus and do it together. Because you select minus 60, that's all right. Okay, we have fx, and for f times x is equal to what? You alright? Are you okay for that? Okay, and then d sigma is what? We define d sigma as dx. Dx is what? Dx is fx divided by f times x. Okay, okay, and then sigma 1 is become, because we define it to be fx divided by f times x, so then it's become this value minus rate. Okay, this one here, right? Okay, and the percent error is what? We have the new value already. Okay, this one minus this one and divided by the new one, the update value, multiply by 100. Okay, here, right? And then for the second one should be the same, but it changed sigma to be the new one. Here, right? And after that, this should be the same. Okay, what did you think? What happened? You select minus 60. This you select, right? You select minus 60. And what's happened? It's not good. Okay, it's not good, right? You select minus 60. And what's happening for now? It's not good. It's diverse, right? That's maybe happen. Okay, how can we do? Okay, change the new one, right? So, which one? Minus 50, right? Okay, sorry about that. I for this cell is not maybe update. Actually, minus 60 should be all right because at the first time I maybe not update the cell, so then it's maybe happen like that. Okay, so if we update the cell, so then minus 60 is okay because my fault is allowed for the next sheet, the next cell. Okay, so you see now from the introduction, if you select minus 60, that's only 3 iterations, 4 iterations. It leads to the solution already. That is the sigma should be 59 point here. And actually we should request more than 6 digits. More than 6 digits are required. Okay. But then the solution is around here that you see is very close. Okay. But it is a solution that we would like to have or not. We require different value of the root, right? But now it is minus 59. That's we already find from the first one. We already know from the first one. So from the initial case that you select, minus 60, it gives us for the same value of the root. So then it's not necessary because we would like to find the different disposal rates. So this should not, if you answer just like this, it's not correct. All right? We prefer another root. We prefer another root. So then if you select the same initial case, you get the same root. That we will not prefer to have that anymore. Okay? So then, which value that we should be select instead? Sorry? 17? Okay. Okay. Now we have another root, right? Another root is what? It is 21.35. Okay? So you will see the answer. Do not answer me from the table, not only the table. Okay? The answer for these cases, it should be falling below here, and the answer should be here. You have to conclude the solution that we have the sigma, okay, is equal to this value, right? At the end of the iteration. Then it may be better for us for these cases to solve the bisection. Yeah, right? You have to conclude it. Write down the solution. Do not copy the table to me. If you copy just only the table to me, so then it means that you know nothing. Okay? You have to answer, conclude the solution. What is the correct solution? Are you alright? Do you understand? Are you okay for that? Do not forget to conclude the solution to me. Okay? Same. For these cases, what is the solution? The solution is what? So at the end of the method, at the end of the table, can we stop? We can stop over here. Okay, that's here. We can stop right now because the tolerance is 0, is very close to 0. So then we can stop. Just 5 iterations, it should be enough. Okay. And what is the value? It should be n here. And the solution should be here, right? Okay, you have to conclude that. The solution that for sigma number 2, it should be this value. You right? Are you okay? Conclude by yourself. Okay, we move to the final method, that is second. Okay. We have just only 1 minute. We do the same, right? But for second, we will approximate. For second, we will approximate the first derivative. For this, we approximate the first derivative. It's not necessary to take the first derivative by ourselves. We approximate the first derivative. It's not necessary to find the first derivative function, right? Okay, but it's required to initial case, right? It's required to initial case. So then as the first one, it should be zeros, and it is the first one. Okay, and the first two initial case is maybe something like this. That is, maybe you may try initial case. For the initial case, which value that you prefer? Value of two value already, right? Okay, minus 55 and 21 or something, I don't know. And we require another value. What initial case should be? What initial case should be? Sorry? 55. 55, right? Positive one. Okay. You select 55. Okay. And then we require two initial case, right? So then this value is maybe another one. That's very close to 55. Okay. What's happened? We may select 55.1. That should be all right, right? Okay. And for fx, it is the same. But we change f here to be what? We will not use the first derivative that we derive. Okay, we use the approximate function. We use this formula instead. Okay, that is equal to what? Is equal to fx 0 minus fx1 and divided by x0. Do not switch it, okay? Because it's related to the sign convention, right? Minus this one, right? This is the approximate value of fx. Okay, and we can do the same thing. If we use the sigma to be fx divided by f times x, like this, so then sigma 1 is become x minus the x. But if you change it for the formula at the same of this green box, if you change it to be here, okay, this should be plus, right? Okay, it is the same. Are you all right? Okay, and then for next procedure, we change this should be the next one, right? Okay, we select is to be the next one. What's happened? What do you think? This is okay? Is convert or not? Is convert or not? Is convert, right? Converts to which value? We can stop just here. Okay, you see the sigma is maybe around 73, right? Why did it stop? Show like this? Because it's very close, right? So then it's very close. So then delta x is very close to 0. So then it's become divided by 0, right? Okay. Okay, so now we can stop here. If we stop, that's maybe the percent error is falling below. It's maybe around here. That should be all right. Okay, and the solution is what? Solution, it should be this column, right? And solution of this value of this time is maybe this one. Are you okay for that? Easy, right? Are you okay? And then we have three principal stress already. Okay. First one, minus 59 compression, right? Okay. Second one, 21. Okay. Tension, right? And the third one, 33. Okay. Tension, right? Okay. If you would like to draw the more circle, okay, this is the additional, you not necessarily draw. Okay. For the more circle is maybe something like this. Okay, we have 23, maybe around here. Okay, and we have 21, maybe around here. Okay, and minus 59, right? Okay, minus 59. Okay, maybe something like this. So then we have three planes. Okay, XY plane, XZ plane, YZ plane. Okay, so then for then it is a sigma 1, sigma 2, and sigma 3. So then it is a 1, 2 plane. 1, 2 plane, we have the circle here. Okay, this is the first small circle. Form your closest, magnitude. So material, you start with just only one circle, right? Okay, but if we solve for three-dimensional, we have three circles. This is the first one for the first plane, and for the second one, it's maybe around here. Okay, so then we have another circle. All right. We did a second one, and for the third one, is this and this. Here, it's a more circle for three-dimensional physical strength. And the strength that can be altered is allowing the shading area. That's only can happen for the material. Are you alright? I hope you enjoy and understand it's more for physical strength. Are you okay for this topic? Are you okay for that? It should be all right. So then I can stop